Guys, welcome to the H2O Spirit channel. Today we are going to be revealing and solving the questions that came out in JAMB mock 2024 in physics. Okay, now look at the board. You have JAMB mock physics questions. Please, you don't have to play around with these questions because they are sure to come out in your May exam. So if you weren't opportune, or if you have written the JAMB mock where you did not perform very well, you have to subscribe to this channel because we have all the questions by the grace of God to release to you, and we are going to be solving them one after the other. If we are not able to finish all the questions in this video, we will do the others by next week. Now, what are the questions we have for you today? Let us look at the board. Look at this simple diagram. The diagram says that if the body is in equilibrium, what is the value of T1 and T2? If you have written JAMB, you must have come across this particular question. So you will check now in this solving whether or not you have gotten the answer or you have failed it. Now, how do we solve this question? Because the body is in equilibrium, remember there is a condition for a body to be in equilibrium. One of the conditions is that the sum of the upward forces must be equal to the sum of the downward forces. Okay, so I think that the upward forces are likely to be this, though these two forces are not directly upward, so we can't work with this. Otherwise, a student who is not smart will think that the sum of T1 plus T2 is 50 and shade 50. If you shade 50, you will fail it woefully. So you have to be very careful because the forces must be vertical. It must be vertical forces. Now, what are the vertical forces here? I think we can do something like this and something like this. Okay, let me redraw this diagram. Let me take a simple sketch of this diagram like this. This is our tension T1, this is our tension T2, and the angle here is 30, the one here is 30, but the one acting down, which is the total downward force, is 50 Newton. Wow, this question is very, very cheap. How do we solve this question? Remember, get the vertical component of this force that is acting upward this way. How do you get the vertical component? Very easy. I have always told my students that if your angle is to the horizontal, which is what you are seeing on the board, then the vertical component is usually sine theta. So it means that the T1 here, your T1, the force that is acting here will be T1 sine 30 degree, while the one acting here is T2 sine 30 degree. So for every vertical force, as long as your angle is to the horizontal, which is this angle that is here, make sure you use T1 sine theta and T2 sine theta. So according to the conditions for a body to be in equilibrium, remember your sum of your upward forces must be equals to downward forces. Please take note of that. And what are the two upward forces? The two upward forces is your T1 sine 30 plus your T2 sine 30. And that will sum up to give us a downward force, which is 50 Newton. So what do we do? Very easy. What do you have in common between this and this? What you have in common is sine 30. So you can bring your sine 30 out so that you have sine 30 degree bracket what? T1 plus T2 equals to 50. What is your sine 30? 0.5 bracket T1 plus T2 equals to 50. So what do we do now? You divide both sides by 0.5. Divide here by 0.5 so that this will cancel this. Then your T1 plus T2 will give us 50 over 0.5 will give us 100 Newton. So please take note, the sum of the forces. Remember, you were told to calculate the sum of the forces, and the sum of the forces, which is T1 plus T2, will give us 100 Newton. So if we have 100 Newton as our answer, let us check the options if we are correct. Option A can never be. Be careful. If you are not intelligent or wise, you think that the answer is 50. No. Option B is not the answer. C is not the answer. The answer is what? D. Now let's take question number 2 and solve it. Let's take question number 2. Now, this question number 2 is a circuit diagram on simple DC circuit. In simple DC circuit, resistors are either connected in parallel or in series. How do I know that two or more resistors are connected in parallel? Very easy. The parallel connection shows that there is a division of current. If the current enters the circuit, the current will be divided across the resistors. For instance, if I have something like this, this is a wire. Now, when the wire gets to a particular junction and there are three different resistors here, this way, when the current gets here, the current will be divided across this resistor. Because there is a division of current, we can say that the three resistors, arrow 1, arrow 2, arrow 3, are connected in what? Parallel. So there is a formula for solving parallel resistors. What's the formula? The formula is that 1 over arrow total is 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. This is the case of a circuit that is parallel. Like I told you, parallel means that there is a division of current. That when the current gets to a particular junction, the current will split. For instance, take a look at this. If the current passes through resistor, when it gets to this place, some will flow here, some will come here, some will come here. So what does that tell you? It means that these three resistors are said to be in what? Parallel. And the formula that will be used will be this. But how do I know that two or more resistors are connected in series? Very easy. If you have a circuit diagram this way, like this, you have a resistor here, another one here. Even though the resistors are bent, it does not matter. It must not necessarily be in a straight line. Now let us do analysis. If we have arrow 1 plus arrow 2 and arrow 3, and the current is coming from here, the current that enters this resistor is the same current that will enter here. There is no division of current. And when there is no division of current, the circuit is said to be in what? Series. The current that, if it is 2 ampere that is here, 2 ampere will also be here, and 2 ampere will be here. Because the current has nowhere to go to. But if there is a bridge here, that another wire is connected, then the circuit will not be in parallel. Why? If the current gets to this place, they will be split. It will split between these two resistors. I can say that these two are in what? Parallel. Because there is a division of current. So whenever there's a division of current, the circuit is said to be in what? Parallel. But whenever the current flows in a particular direction where there is no division, the circuit is said to be in what? Series. Now, the question that came out in your mock JAMB in physics exam, the recent mock JAMB that was conducted, was this circuit diagram. How do I solve this problem? Very easy. Do your analysis. If you watch very well, you will find out that resistor 1, resistor 2, and resistor 3 are in what? Parallel. What is the formula for parallel resistors? I told you 1 over arrow total is 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3, depending on the number of resistors. So in this question, we have just 3. So we are going to combine these 3 in what? In parallel. When we are done, we will now combine them in series together. So let's quickly do that. 1 over arrow total will give us 1 over 3 plus 1 over 3 plus 1 over 3. The LCM of 3 will give us 3. And if 3 divided 3 is 1 times 1, 1. 3 divided 3 is 1 times 1, 1. 3 divided 3 is 1 times 1, 1. That will give us 3 over 3. So therefore, 1 over arrow total will give us 1 over 1. Because 3 divided 3 is 1, 1. So if you cross multiply, you have that your arrow total is equals to 1 ohm. Please, don't be quick to look for your answer in the option. This is for resistors in parallel. Now that we have combined these 3 resistors in parallel, let's see how the circuit diagram is going to look like. The circuit diagram is going to be like this. This is your resistor, which is 4 ohm resistor. Then, if you combine these 3, you have 1 ohm, like what we just did now. Look at it. We have 1 over arrow total equals to 1 over 1. If you cross multiply this with times, so your arrow total is equals to 1 ohm. If you combine these 3 resistors, you have 1. So this is 4 ohm resistor. 1, 2, 3 has been combined to give us 1. So you have 1 ohm resistor here, and then you have another resistor, which is your what? 3 ohms resistor. Now, can you please tell me, class, These three resistors you are seeing on the board, are they in series or they are in parallel? Very easy, they are in what? Series. Yes, they are in series. Because the current that flows here, that's the current that enters here. So you can get it now. Arrow total, the total resistance becomes 4 plus 1 plus what? 3. And that will give us 4 plus 1 is 5 plus 3, that will give us 8 ohms. So what's the answer to the question? Is not A, it is not B, it is not C. The answer is what? D. Okay? We are going to take few more questions on this. Now, this question also came out in JAMB 2024. This particular question, was also there in your mock exam. Maybe you must have forgotten it or you came across it, you couldn't solve it. Let me show you how you can easily solve this question. Very easy. What is the energy of a what? A photon with 600 volts. Then the electronic charge, this is the charge of electron. You can call this quantity of charge 1.6 times 10 raised to the power of minus 19 coulomb. That's why it is given to you in what? In coulomb. Very easy. Remember that you cannot solve this question with the normal energy of photon where you have something like this. You cannot solve it. You have to go back because this is the potential difference of the photon. So we can say that the volt is 600 volts, okay? Then the quantity of charge, which is the charge of electron, is 1.6 times 10 raised to the power minus 19 coulomb. We are looking for the energy or the work done by a photon. Remember, the energy and work are both measured in what? In joules. How do we solve it? Remember, potential difference is the work done in taking a unit charge. Okay? If you make your work done subject formula, you have work done is equals to volt times charge. So very easy, we have come to the conclusion of this question. What is our volt? Our volt is 600 times the quantity of charge, which is 1.6 times 10 raised to the power of minus 19. So we have to multiply this by this. Let's quickly use our calculator. Remember, if you had written this exam, there's no way you can press exponential values. So you cannot press 10 raised to the power of minus 9 because of the kind of calculator that was given to you. So what do? Multiply your 600 with 1.6 first. Do that first. Okay, let's quickly multiply 600 by 1.6. (600) times 1.6, that will give us 960. So you have 960 times 10 raised to the power of minus 19. So what do? Remember, you take your point from here, 1, 2. You have moved 2 times, so you have 9.60 times 10. If you move 2 times, you add 2 to the power, and that will give us minus 17 joules. Let's see whether we are correct. Yeah, our answer is not A. Our answer is not B. Yes, our answer is not C. D is 9.60 times 10 raised to the power minus 19. So that's the answer. Okay? Yeah. Now let's go to the next one. Calculate the wavelength of X-ray when 400 photon is applied to an X-ray tube. What is the wavelength of an X-ray when 400 voltage is applied? So our potential difference here, our potential difference V is 400 volts. Now they gave us our Planck constant, they gave us the speed of the photon, which is the speed of light, and they gave us our electronic charge. Now, so our charge is 1.6 times 10 minus 19 coulomb, and this is the speed of light. Remember, there's a formula that says that EV is equals to HF. Okay, but this question actually do not involve frequency. And remember that in your general wave equation or in your electromagnetic wave, V is equals to wavelength times frequency. So if you make your frequency subject formula, frequency will give us V over lambda, as in dividing both sides by lambda. Remember that this V is called the speed of light. So you can still say that frequency is C over lambda. This C means constant, which is the speed of light. So you can put it here to have EV is equals to HC over lambda. So if you have come to this point, it means that you have gotten the answer to the what? The question. Now we are looking for the wavelength. What do we quickly do? Let's create a space for us to solve this particular question. So if you have EV is equals to HC over lambda. What is your E? Your electronic charge. V is your potential difference. This is your Planck constant. This is your speed of light. Like I told you, V is the speed of light, so it's constant. And this is your wavelength. You're looking for wavelength, you can just switch by doing wavelength is equals to HC over EV. So let's do it. Here you have 6.6 times 10 raised to the power of minus 34 times speed of light 3 times 10 raised to the power of 8 over your electron is 1.6 times 10 raised to the power of minus 19, and your voltage is 400 volts. So you have 400. Wow, that's quite interesting. Now what we are going to do, remember you can have to multiply this by this. That's multiply. And you do the same, you multiply this by this, that's multiply. Don't touch the power yet, so you are not going to make mistakes. So let's quickly multiply these two values. 6.6 times 3, 6.6 times 3 will give us 19.8. So if you multiply this by this, be careful, you have 19.8, then you have times 10, pick one of the 10, combine it by the laws of indices, minus 34 plus 8, all over. Now 1.6 times 400, that's 640. So you have 640 times 10 raised to the power of minus 19. So what do? We can now divide these two values together. Okay, if you divide 19.8 over 640, you have 0.031. If you divide these two, you have 0.031. Okay, then times 10. Remember, if you combine these two, you are going to get minus 34 plus 8. You have minus 26. So the power here is minus 26. That's what you have. The power here is minus 26. So minus 34 will give us minus 26. So what we have now is 10 raised to the power of minus 26 minus 19. Don't forget, in indices, when you are dividing, you minus. So this minus will give us plus. So you have 0.031 times 10 raised to the power minus 26 plus 19. Let's quickly do that. Minus 26 plus 19. That gave us minus 7. So you have 0.031 times 10 raised to the power minus 7. Okay? So what do we quickly do? We move our point from here to here. So you have moved 1, 2. That's 2 times. So you have 3.1 times 10. If you move this way, you have to increase the negative number. So you have minus 9 meter. So this is the wavelength of the X-ray when 400 volt is applied to the X-ray tube. Finally, we have come to the end of this video. We have a lot of questions to review to you. So if you know today is your first time for coming across the channel, do well to help us subscribe. Click the notification bell so we'll send the other questions that came out in your mock JAMB in physics, it will get across to you. Thank you very much for your patience and support. I will see you in my next video.